These last two examples are all calculator based, and actually this is problems number 12 and 13, so we're going to handle those together. Let's look at problem number 12. Problem number 12 is what is the range of f of x equals to x squared minus 4? Is it all real numbers, all real numbers greater than or equal to -4, all real numbers greater than or equal to 0, or all real numbers less than or equal to 12, equal to 2? Just graph it, and let's just look at the range. So let's graph x squared minus 4. X squared minus 4. Graph that, you get this graph right here. And it's actually pretty easy to identify the range. The range, we look at the y-axis, and I'm just going to kind of draw what the range looks like here. This is the lowest point of the range. And you go from the bottom of the graph, and the graph actually never stops, so we keep on going. So our range is actually this line right here, which I'll color it just so that you can see it better. I'll make it red. Okay, so that's the range line. Let's describe that line. It is all y values greater than -4. So our range of, if I was just going to type that up, our range is, let's see, I'll just type it up. So our range is y greater than or equal to, I want a greater than or equal to, because there are no open circles there, equal to -4. Okay, so that's our range. So let's look at our choices. And that is obviously B. B is our choice. All real numbers greater than or equal to -4. Okay? So let's look at problem number 13. 13 says, and got all this right here. All right, try 13 says, a home improvement store sells several sizes of rectangular tiles as shown in the table. Okay? The store begins selling a new size of tile with a length of 9 inches. Using a appropriate model, estimate the area of a tile of this size in inches squared. So we're going to enter the values into listing spreadsheets, use a quadratic regression, and use the table, use the graph, use the table. That's just a horrible sentence. I'm going to get rid of it. Okay? And then we'll just graph it and look at the table. So let's get this entered. Let's first go to listen spreadsheets and enter this. All right, listen spreadsheets, home screen, and let's go to list spreadsheets. All right, I'm going to enter that, follows. Okay, again, here's the data, and I've entered it into TI-Nspire like this. So I'm going to put my cursor in cell C1, and we're going to go menu for 1, and we're going to use a quadratic regression. Normally, well, we've used a linear before, but today we're using a quadratic. And I will explain this a little later why. Okay? Now we use a quadratic regression. We've made our X list. We've made our area, the Y list. And we're going to save this actually to, well, I already have stuff in other graphs. So I'm going to put in F1 actually. I'm just going to leave it in F4. Press OK. All right, and so we have our regression here. Now let's look at F4. Let's go home screen. Let's go to graphs, and let's go up to F4. That's where our quadratic regression is. Press enter, and that's how it looks. Let's look at the table. Hit Control T for table, and let's go to where X stands for the length of the length of the size of tile. Let's go to where X is 9. If we go to where X is 9, we get a length of 129.925, and if we round that, that's about 130. So that helps us get our answer here. So we're going to, I don't know where I'm on this page 4. Okay, that gives us a 430 areas of 130. Now, the question is, why did we use a quadratic regression? All right. Let's look at the data if I was to, first of all, let's look at the data. This is data we originally had. If I go to data statistics, and I go to look at length versus area, that's not exactly a straight line. And if I do a quadratic regression there, it actually gives a pretty good fit. So this is the reason why we did a quadratic regression there, appropriate model.